This is lesson 43 of the Quantum Mechanics, a mini lecture series, part 2 of the discussion on a simple quantum system. So let's take two cases. Let's take the classical case, and let's take the quantum case. Classical case. Well, in the spinning top example that I gave, there are two possible spin states. Okay, let's call it 0. Let's call the spin down state 0, and let's call the spin up state 1. Okay, so the spinning top is when it's spinning downwards in a downward direction. Okay, the long pointy thing is pointing downwards as such. We'll call that 0. Okay, it's just an arbitrary notation. Spin up, it's pointing upwards. And we could have chosen other numbers or letters, okay, to denote electron spin. But by convention, we use 0 and 1. You can also think of these two states as being the two different states of a light switch. So a light switch could be off, okay, 0, or on, 1. Let's go to the quantum case. Now let's take the spinning top as being an electron. Now, since an electron is found to be in a superposition of spin up and spin down states, we can write the superposition, this expression, as follows, okay? Prior to measuring the electron, I should say. And you might be thinking, what on earth are these funny looking brackets, these symbols here? Well, this notation, okay, is called bracket notation, bracket notation. Okay, developed in 1939 by the English theoretical physicist Paul Dirac. This symbol here is called a ket, and this symbol here is called a bra. Okay, I don't know where these names came from, but they were the names given by Paul Dirac. And usually a bra is written before a ket. Usually a bra is written before a ket in a quantum mechanical expression, as we'll see later on. Okay, so that's why we get the word bracket. And a ket and a bra is just another way of saying, so something like this, just another way of saying everything we can know, everything we can possibly know about the quantum system, okay, mathematically. Okay, the use of a bracket notation only applies to quantum mechanical objects, okay, objects on the tiniest of scales, the microscopic scales. And this Dirac notation is pops up everywhere in quantum mechanics. It's very important, as we'll see. And so the next thing is that, well, in quantum mechanics, we can't actually say whether an object is behaving this way or the other with certainty. We can only say whether or not the object will behave a certain way in a probabilistic manner. Okay, you can only talk in terms of probabilities. In other words, the electron might be spinning in the spin up state 50% of the time, let's say. This idea of probability on the quantum level is something which is intrinsic to the quantum level. Okay, it's there. Things behave in a very uncertain way down at the microscopic level. Okay, so this here, 0 plus 1 using Dirac notation, bracket notation, is telling us that the electron exists in a quantum superposition. Quantum superposition of the states 0 and 1. Okay, it's in both states at the same time until you actually measure the spin state of the electron. And then the electron is found to be either in state 0 or 1. Okay, so this is before measurement. This is after measurement. Okay, you get numbers. When you measure something, you get a number, not a state. Right? And in the next video, I'll explain a bit more further as to how we get probabilities using bracket notation.